evolution. And then we'll go more into kind of discovering and exploring the role of agentic AI in enterprise chatbots. And after that, we'll sort of like dive deep into digital human case studies and what people are developing with solutions or with technology like digital humans. And then more importantly, we're gonna go deeper into the tooling that's available to you and the models that are available to you to make such enterprise chatbots and bring yours to life, right? And then at the end, we kind of like want to make sure that you leave this session with some of the best practices that we think would be critical in embarking on the journey of having a digital human interface as your enterprise chatbot. So with that, let's just go first into the first topic. And this is a very complicated diagram, clearly.
Artificial intelligence that holds immense potential for addressing various challenges faced by enterprises. While many customers have previously explored AI.
That is so cool. Yeah, that was awesome. I love surprises. They keep you young. Okay, so anatomy of a chatbot, right? An extremely simple overview of what a chatbot is, right? Instead of complicating the entire ecosystem of all the things a chatbot could have, at the most fundamental level, what are the two components that a chatbot embodies? One is on the left over here, we have context, right? For any chatbot to function, it needs to have some level of knowledge, some level of data, some level of action, orientation, or information with which it operates on, right? And on the right side over here, we have the interface. How should this enterprise chatbot or a chatbot interface with the customer or interface with the user that you want to be talking with the said data, right? So let's take a look as to how both of these components have been evolving over time, right? When you think about the enterprise context or the knowledge piece of this chatbot, we all remember the good old days of the NLP, the natural language processing, right? I mean, I'm sure we all have found ourselves into the era where we were writing dialogue flow dialogues, beautiful IBM Watson dialogue trees, and I mean, I remember those times. Love it, maybe. Kind of, right? What were they good at? What were they excellent at was providing structure and, right, providing depth of knowledge from an expert, handwriting and hand codifying the information into a dialogue tree. Where did they fall short? Well, they fell short on the sheer fact that they were too rigid, right? The moment the user steered away from the prescripted sense of conversation, suddenly everything fell off the rails, right? It couldn't respond, it cannot handle anything, there were no escalations that were handled. Basically, there was no spot for fluency. Then came LLMs, and everything just changed in the world of chatbots, right? What are LLMs so great at? What did they brought to the table? Well, they brought the fundamental principles of fluidity and just conversation, like they could go anywhere, right? Sky was the limit, where you could talk about anything to everything with the chatbot using an LLM. That said, anything to everything, I'm sure all the enterprise legal teams love to hear that, right? And this is where they fell short. Essentially, LLMs provided a very good mechanism or foundation to provide fluidity to the conversations of a chatbot. However, there was no rails. They could literally talk anything to everything. So then came RAGs, Retrieval Augmented Generation. And with RAGs, we started codifying, okay, how do we provide some level of data, some level of structure, some level of knowledge to this immense world of LLMs to power our chatbots with something that is relevant to it? Hey, how can we give it some role, right? How can we give it some knowledge? And while knowledge is great, what knowledge doesn't provide is any kind of control, right? Knowledge provides context, knowledge does not provide control. So this is where we are today, the era of the agents, right? What do agents bring to the table that builds up on the foundation of LLMs and RAGs from the times before? Well, agents bring the sense of they get the knowledge and the context from RAG, they get the fluidity from the LLM, but they also bring back some of the good sense of control and orchestration and role definition that NLP era was able to do, right? And this is where we are today. And this is how context has evolved over the years. So now when we look at how interfaces have evolved, well, we love these pictures, right? Reminds us of a very good old time, now potentially sitting in a museum. But this is how we used to interface with computers. not too long ago, actually, right? Then came the touchscreen Apple devices, where we redefined how we interface and communicate in a very tactile way with the machines. But then for chatbots, the real advent of the technology came when conversational AI started developing, right? When came the era of voice assistant, when came the common principles of ASR and TTS, where you were able to actually, from speech, communicate with the computers, right? From most basic commands. But then they were so limited in the scope of what you could do with them, right? Then came LLMs, and they changed everything for us, right? Because they brought in, to my point, conversational naturalness and fluency that didn't exist before. But when you combine the core concepts of a voice assistant with the concept of an LLM, you're left desired in a place where, how can I truly interact with this machine without lifting a finger? How can I truly communicate with the machine in a way that I am communicating with a colleague? And this is where we believe an embodied agent, such as a digital human, plays a great role. We truly believe this is going to be the interface with which agentic AI applications are going to be brought to market for communicating and providing customer service and support. And why do we believe that? Because an embodied agent does several things, if done right, of course, right? One, it provides that natural interface of voice communication, has the back end of an LLM to provide fluency, but more importantly, has that embodiment to feel like, hey, I'm not communicating to a machine. I can actually have a dialogue. I can actually converse, right? And I can actually iterate. And this is why we believe agentic AI enterprise chatbots will become in the future, right? They will have, through the power of agentic AI as their backend, they will have the capability to make proactive decisions. They will have the capability to do tasks. They will have the capability to autonomously execute events and things for and on behalf of the user. Look at each of these roles that are on the screen and look back at your own enterprise, right? Look back at where you work. These are not roles that are foreign. These are all assistants that we potentially could have had to augment our own workflow. They are across every single vertical of industry, and they're across every single role, because every single role can do better with respect to focusing, where us as humans can focus more on the tasks that are so privy to us and creative for us, while AI agents can help support and augment the tasks that are labor intensive and are potentially debilitate the capability that we have. So let's take a deeper look at some of these use cases that are happening in real time in the world out there, right? These are some of the use cases our partners have already developed. And I take this example of a virtual hospital assistant as the digital human as the virtual hospital assistant because it's such a powerful use case. Because it does so many things for both the nurse practitioners as well as for the people who are visiting the hospitals. Raise your hand if visiting a hospital is a very pleasant experience. Anybody? Oh, really? Sir, tell me more. You think it's a pleasant experience visiting a hospital? Okay. And I think this is the crux of it, right? Everybody is, it's the sheer definition of chaos. Everybody, it's proper chaos. People visiting the hospital, people on the other side receiving these angry people coming into the hospital and anxious people coming into the hospital. It's the perfect scenario for everything to go wrong, yet everything functions. And everybody on the other side is just operating. They're not feeling that they're welcomed in that situation, right? So when we look at a problem statement such as this, there's so much exploration and so much possibility for a digital agent or a digital human to action and insert themselves and support the processes along the way. So this is an example of that, right? Where the digital agent is empowered to have information like health records, policy records, dosage information, care protocols, et cetera, through various databases that the hospital has and through various microservices that NVIDIA has built on top of them to extract critical information and timely information to make questions as simple as, hey, when is the next dose of this particular medicine that I'm supposed to take? The answer's right at your fingertips, right? And or help nurse practitioners do their jobs faster by being able to pull in patient history and communicate it to them in an agent assist way that was not possible before. And this is, like I said, just one example. We've seen the digital human use case expand and permeate across many different verticals, right? We've seen virtual care assistants and preoperative and postoperative care being used. We've seen sportscasters, virtual sportscasters and sports analysts delivering sports insights in real time. We've seen digital concierges and M&E and enterprises to help onboard customers and users faster. Most importantly, we've seen a lot of use cases where employee onboarding is such a big challenge. Learning and development, gone are the days where you have to see the same repetitive video over and over again or spend trillions of dollars in just trying to retain and create learning protocols for our employees. You have to make that life simpler, easier, better, and more communicative, right? Similarly, two other industries where we've really seen a remarkable growth in is financial advisors or AI-supported financial advisors, just because, well, that industry can really support with having personalized insights. Imagine being as a user and having personalized insights on financial events, on stock values, on just things how you should better invest your money, right? And then, of course, virtual shopping advisors helping augment the user's journey through a retail workflow. Here's an example of a particular use case where a digital human was utilized as an agent in an agent assist format in a banking institution to help elevate their support capabilities that they can provide to the customer. And why is that important? Now, imagine somebody in a bank who's only allowed or trained on limited information and limited data to support only these limited use cases for their users who are stepping into the bank. What happens when you come in with something that requires an escalation, right? You come in, they ring up their manager, they ring up their line manager, they go onto a call line, they try to get the manager for you, and they try to process this application, and this whole thing takes far too long. Here's an example of a virtual fraud assist use case that, like I said, happened in a banking institution, which helps escalate that process so much faster.
Let's start by opening a claim form to document the client's issue. Please open a claim form on your client portal to enter additional information about the client's case. Shall we proceed?
Yes.
Next, we need to authenticate the client. Can you please ask the client for their first name, last 4 digits of their debit card number, and 3-digit CVV? We'll need this information to verify their identity.
It's Robert Kent, 5227783.
The client has been successfully authenticated.
So yeah, I just took a small clip of the authentication flow, and now imagine the authentication flow trying to narrate your numbers into a system, into an archaic system, or again, somebody trying to take this flow into trying to support somebody's fraud use case, which they're not trained on. By having these agent assistants at your fingertips, you are giving your employees power to resolve your customers' issues faster, feel more empowered in their own role, without necessarily having to go through seeing the customer in pain and agony and, wasting time. So with that, I think I'll pass over to Rupa, who is going to talk about the tooling that's available in the NVIDIA ecosystem to help build such use cases.
Thank you, Trisha. Hello, everybody. In this section, I'll be talking about, like Trisha said, tooling, NIMs and blueprints, and microservices. So I'm assuming you all know what NIMs are. NIMs are NVIDIA Inference Microservices, and we also have ACE microservices, which we have talked about in prior GTCs, and I'm sure many other sessions at this GTC. So we not only provide, and of course, blueprints. So blueprints are reference workflows that we provide, and we provide these as building blocks and not just a single blueprint, but what I'm going to talk about is how do you compose multiple blueprints that we provide to build or to get to the embodied agent that Trisha was talking about. And going through this journey with few of our partners and so on, we have simplified this journey quite a bit. And the main critical blocks, the way we divide and conquer or building or getting to the embodied agent is treating the agent's brain as a knowledge agent separately from the digital avatar piece, right? Those are available as 2 different blueprints and different variations in that thing that I'm going to go through them in a second. So this, what I have on the screen is a simple RAG agent, a knowledge agent, right? What we think is before you connect your digital human to or get to a brain of the digital human, you first think about how do you build the brain, the knowledge agent? And for that, we provide a foundational RAG blueprint. We call it foundational because it's a simple retrieval, multimodal retrieval with ingestion blueprint, which is available on build.nvidia.com. There's a link there. And you can insert documents and knowledge, as basically enterprise knowledge, into it. The second one, we also have another blueprint for video search and summarization. And in this, this blueprint is actually capable of taking your knowledge that exists in videos, translating it into unstructured and also structured. There's a structured piece to this as well, as shown in that RAG there, graph RAG. So this is another form of knowledge, building of a knowledge agent. And as you've seen in many talks, and as Trisha was saying, most of these knowledge agents are agentic. And yesterday, we announced a library and a blueprint to make building knowledge agents easier with agentic AI. And agentic AI, as you see here, there's the RAG is fronted with an agent that can plan, reflect, refine, and so on, which you would want in any kind of a knowledge brain or knowledge agent. Next. So and this is, again, a journey towards embodied digital human agent, right? You can go directly to the agent, the digital human avatar that we'll talk about, or a blueprint that we'll talk about in a bit. But you can also take one step and make it conversational by using some of these ACE microservices, Riva, ASR, and TTS NIMs, which you can bring them, and there are examples of connecting them to the agent. And as you might have noticed, in every transition, the agent connects to in this case, the agent connects to the ASR and TTS, whereas the TTS by a single prompt and response API, right? So the point is the brain always provides a API endpoint, which is a prompt and response. That should be response there on the screen. It's a typo. And the next, here's where we come to the embodied agent part, where you bring the digital human blueprint, connect it to the agent, your knowledge agent. And again, it's via an API. So the best practice, or a recommended practice of building this end-to-end workflow, is breaking them into two pieces. The digital human blueprint, the reference that we provide, you use that to connect to your digital human, build your digital human, your avatar customizations and so on, connect it to, for example, an LLM endpoint to begin with, any OpenAI or our NIM APIs, perfect that digital human, and then also, in parallel, you can build the best agentic knowledge agent and then connect them via just an API endpoint, API connection. So that's how we think you can succeed to building end-to-end pipeline. And in this process, you will learn that for the best end-to-end experience, which Pascal is going to talk about in a bit, you'll have to tune both blueprints on their own to get that perfect end-to-end experience. And last but not least, we also have a data flywheel blueprint, which has been talked about in various sessions in this conference, which will be released post-GTC. Basically, this is to perfect or make your models, all the AI that is used in the end-to-end pipeline, whether it's retrieval or the ACE NIMs. Perfecting it over time, we do provide NEMO microservices. That's all I have, and over to Pascal.
Thank you. Perfect, thank you. All right, so yeah, I'm going to dive a bit deeper now into this digital human blueprint, and in particular, I'll focus on best practices of what are the aspects you need to take pay particular attention, and at the very end, also give a few pointers to how you can get started with digital humans. Before I start, let's start with a quick demo. What you can see here is a preview of the next blueprint we're going to release very soon. It's version 5.0. If there's one thing I want you to pay attention, then it's the improved latency overall, and also the improved latency in terms of margin. That's especially for those that know the previous version that we have released. Take a look.
Hello.
Hey there. How are you?
I'm doing great, thanks for asking. Just immersed in all the exciting tech showcased at GTC 2025 and can't wait to learn more about the latest advancements. What brings you here today?
I know, it's a lot. I just was hoping we can just chat and play a game.
That sounds lovely. I'd be happy to chat with you here at GTC 2025. What drew you into our conference this year?
Forget the conference. I want to play a game, okay? So I'm going to ask a question, and why don't you answer?
Sounds like fun. Go ahead and ask your question.
Okay, knock knock.
Who's there?
Oops, that's a digital human.
As a digital human myself, I should have seen that one coming. What's the punchline you were looking?
Did I get you?
You got me good. I'm impressed by your digital human insight. Did you know I'm created by people who build AI and graphics software at NVIDIA?
Well, apparently you wearing the NVIDIA colors was a dead ringer.
Those green and silver colors are definitely a giveaway, aren't they? What do you think about our digital human tech?
What are you most excited about at GTC?
I'm super excited about the advancements in RAG and how they're changing the game for digital human interactions like our chat.
I know, right? Like, I can't help but feel how good it is to talk to you. It's like talking to a knowledgeable friend.
That's it. Thank you, Trisha, for making this amazing demo. So let's jump right into it. What you saw here is our brand new reference workflow. So it's a starting point to create such digital human. We have drastically reduced the complexity of the workflow, mainly by unifying a collection of microservices, 5 services, into what we call now the ACE controller. And that's the component that's orchestrating a whole collection of NIMs and other microservices. We have also refreshed the workflow in general by updating the NIMs to their latest versions. And we have updated or replaced the renderer, and we're using now the Unreal Engine, which has some nice characteristics I'll get to in a moment. And so, as I said, this reference workflow is a starting point. So customization or changing this reference to your particular needs is very important. And that's why we've also focused a lot on improving the developer experience. So one key component of that is the ACE controller. It's now based on Python. It centralizes a lot of functionality that used to be distributed before, that used to be not open and customizable. And it's also based on the PipeCat library, a very popular framework to build such pipelines. We have added support for all the NVIDIA NIMs, from ASR to TTS to LLMs, and also all the animation-related microservices. And this is in addition to the vast ecosystem of integrations that PipeCat already offers. So it's going to be very easy for you to swap out the TTS or ASR service with some alternative, or even integrate your very own. Part of the developer workflow is also to not disrupt your current practices. So we made sure that you can actually develop this ACE controller on your local workstation while all the other NIMs remain in the cloud. So you can use your favorite IDEs, your favorite debuggers, profilers, whatever you use as a programming environment, and create a custom controller for your needs. In addition, we have also added open telemetry tracing to ACE controller, so you have better introspection into what is going on. And in case of troubles, you'll have also a very powerful tool to debug latency or other challenges. Besides the developer experience, we've also looked at simply configuring an existing pipeline. This is especially important for creative tuning. For example, you would like to tune a prompt, or you would like to tweak some visual aspects. And for that, we have introduced a new configuration tool that we call the ACE Configurator. It's a tool that allows you to reconfigure an already deployed microservice at runtime. So this becomes very powerful to do quick iterations, replace a scene, tune facial animation parameters, and so on and so forth. We have also, thanks to the new Unreal Engine render that used to be in early access, which will be released as a GA service, we now also have access to Epic's ecosystem, and in particular to the MetaHuman creator that allows you to create a custom avatar in a few clicks. Scalability side, we have disaggregated the blueprint. So not only the RAG lives in its own blueprint, but we also have the individual NIMs like ASR, TTS, and audio to face, which can be deployed and scaled independently. And this, in addition with the Unreal Renderer, which is a raster hybrid rendering engine, which performs much better in terms of scalability than what we used to have. On the user side, we have put a lot of effort on improving latency end-to-end, so from the end of the user utterance to the first response of the avatar, and as well as the barge-in latency. Compared to our previous release, we have improved end-to-end latency from 2.7 seconds down to 2.2. And on the barge-in side, we have even a bigger improvement from 1.9 second to 1.3. This brings me to what Rupa was talking about, the knowledge agent. So I use this expression to either reference an LLM, a RAG, or an agent itself. In general, latency is key. We are building here a real-time application. So we're simulating a human, and we have basically an upper limit on how long it can take until the avatar responds. And we always have to look at latency end-to-end. So as an example, one important aspect is to make sure that we are using streaming on all components. ASR, TTS, the LLM, they can already forward data while they are still processing the last chunk of the previous, of the request. And also in general, we care more about time to the first sentence rather than the time to the first token. Again, in the spirit, we can only, or for the user, it's only relevant when they hear the first sentence being spoken, and we don't care about technical metrics, or at least not directly, like the time to the first token. So latency, of course, depends also on the LLM being used. A rule of thumb is the smaller the LLM, the faster it will be. We made very good experiences with the Llama 3.8 billion instruct. And also reiterating what Rupa has already said, our recommendation is to develop the agentic part in isolation from the digital human, to not complicate things too much. So tweak the accuracy, tweak the performance of your RAG, for example, in isolation before you combine it with the digital human blueprint through a relatively straightforward API. Linked to that is also scalability and concurrency, something to keep in mind. It's not about the single stream. These applications are designed to scale to hundreds or thousands of users. So you need to make sure that your system scales with multiple requests. One thing is re-rankers. From our experience, we recommend using them only when the knowledge base is large and accuracy is poor. And the table on the right also shows the impact of hardware on the latency. So I have two examples, one system with 8 H100 GPUs at the top, and on the bottom 3 L40S GPUs with the same type of RAG. And if you look at a few of these metrics, you will see that the time to the first token and the first sentence latency for a single stream on both systems is roughly equivalent. I would say even for the L40S, it's slightly better. But if you go down the table to the 15 streams, you will see that the latency for 15 concurrent requests increases drastically for the system that only has 3 L40S GPUs. And you always have to optimize for the worst case scenario where you might be processing these 15 streams. So as you can see, the latency will almost double in that case. Next, I would like to talk about avatar customization. That's another thing you very likely will want to customize. As a starting point, we provide the character you can see on screen. It's a high quality character, high fidelity avatar. However, as a drawback, it's quite hard to customize it or adapt it to your use case and make it your own. So as an alternative, we can again use the newly introduced Unreal rendering microservice that leverages Epic's Unreal Engine and the MetaHuman creator. You can create in a few clicks a custom avatar, and you can also benefit from all the quality settings that are baked into these assets to tune basically the trade-off between quality and number of streams that you can run on a single GPU. I have two examples. For example, if you use the medium quality setting at 720p on an A10 GPU, you might reach about 6 streams. At the same time, if you increase the quality to high, increase the fidelity, the resolution to 1080p, the number of streams might drop to 2. So in general, it really depends on your renderer settings of how many streams you will be able to compute on a single GPU. And as a general rule of thumb, it also depends on the scene complexity. You might not just have an avatar, you might have an entire scene, you might have different lights and other things in the scene, and they will impact the CPU utilization for rendering. Last but not least, there's a third option to create a custom avatar. For that, we will provide a template project which is set up with the most important functionality, and you can then drop in whatever third-party avatar you have from Reallusion or from any other provider. You can also leverage the Unreal ecosystem. Again, there are thousands of tutorials and instructions of how you can customize these scenes. There is, however, some requirements. You will need good digital content creation tool skills like Maya or Blender, and this might be a barrier of entry to do that. And one requirement is also that you will be able to prepare your asset and create the 52 ARKit blend shapes that we currently use. Last, I also would like to talk quickly about voice. So we offer through NVIDIA Riva names a wide range of Riva voices that can be used or that are implemented by default in the Digital Human Blueprint. However, we can also extend that with any third-party service, not only 11 Labs as we did in the past, but now through PipeCat, through all the existing third-party integrations, you will be able to use others like Artesia, DeepGram, and basically, and many more. Two things I want to point out here is that please check that the implementations and the APIs underneath support streaming. Not all the implementation can process or can deliver audio chunks as a stream. So this will affect, again, latency, the thing we care so much about. And also not all implementation provide the same granularity of data while they are streaming, which might affect, again, how the pipeline performs. This is also linked to the audio-to-face microservice, which generates the facial animation and the lip sync. We have a lot of parameters and knobs that we can tune to control how these animations are generated. We can control the shape of the mouth when the character says the letter O. We can control how intense the jaw motion is. There are a lot of little knobs which allow us to control the visuals of the animation. The animation also depends on two things. One is the chosen voice, as well as the avatar model itself. Yeah, we have a new workflow with the avatar configurator that will simplify these things. That's almost it from my side. If you want to get started, there are two things. One is visit build.nvidia.com to try out these avatars yourself and get inspired. And the other option, once you want to get hands-on, is to go over to GitHub and check out the Digital Human Blueprint, where you can find how to get started, how to customize it and deploy it at scale. Currently, this is not yet at the 5.0 version, but we're going to release that very soon. Thank you very much.
Thank you, Pascal. Thank you, Rupa, and thank you, Tricia. Thank you for being here. And we have a few minutes for some questions. We'd love to hear from you. So if any of you would like to ask that question, let me know. Raise your hand. Okay.
What are the ethical or design principles around when to use a human-like avatar versus just kind of a voice or something that is obviously not a human?
Can you repeat the question? So when to use an avatar versus a voice only?
Yeah, kind of like the ChatGPT kind of bot, right? Where it's like a dot with some lines, right? That's obviously not meant to look like a human being with emotions. What are the ethical and design principles about when to use kind of the ChatGPT like model versus this human-like model?
I mean, it really depends what is your goal that you would like to achieve. I think the main thing that an avatar adds is the ability to express emotions, to create connection with a human on an additional level, something that you can do with voice, but in a less direct capacity. So it's really hard to say in general, but if your use case requires these things, then I would go with an avatar.
I also think that at any given point, the objective is not to mimic human or mimic itself to be a human replacement of any kind, right? There is also declarative principles that we recommend our partners when they go into that, hey, I'm a virtual practitioner. I'm a virtual fraud assist agent. I'm here to help support you on this journey, but I am not a replacement for a human interaction. This is more so that you're at ease with this communication. That's what the objective is. And I think that is the core tenet of determining if a personification needs to be photorealistic, human-like, versus not.
What I'm asking is, if as you're putting these tools out there, are you also putting out principles
Yes.
when to use these tools?
Yes, we are. Absolutely. Absolutely. So specifically, we look deeply at the stage in which the user is at when this interaction is happening. We also recommend the use cases to have certain level of depth and sincerity associated with it. So there is not for every use case that we recommend such an interaction. But more importantly, when partners are designing avatars, we make certain that they take into deep consideration the the in avatar design principles itself, the kind of avatar that they're designing, and its resonance with their customers as well as their end users, because that's extremely important as well. And then we also highly recommend the declarative notion that it is virtual and it is not something that is anything more than an embodiment of an AI agent.
I'm sorry for interrupting, but it's all the time that we have. I want to thank you all for joining this session. And if you have any further questions, please join our speakers in front of and discuss further. Thank you very much. Enjoy.